Hi, everyone, and welcome back to another really exciting video series with Mrs. Roberts. So in this video series, we are going to go over solving trig equations. So we spent a lot of time on verifying trig identities, but now we're going to be solving some trig equations. And so the first thing I want to do is I want to take some time and make sure we understand the difference between an identity and an equation. So a trig identity is something like sine squared of x plus cosine squared of x equals 1. If you look at this, it is always true. It doesn't matter what x value we plug in, and we could even make, we could call this f of x equals, and we could call this g of x equals. And if I make a table of values and I put f of x and I put g of x next to it, it is always, always, always true. It does not matter what our input is, the output will always be 1. And that's what makes it an identity. Now, the difference between an identity and an equation is not always true. Let's say we're trying to find out when does sine of x equal, we can even do 1. When does sine of x equal 1? Well, it equals 1 right here, and here, and here. So pi over 2, and then let's just put in pi over 4 just for fun. And let's put in 3 pi over 2. And what you're going to see is that these are not always the same thing. So if they're not always the same thing, we want to solve for when are they the same thing? That is what solving a trig equation is all about, is solving for when is this true? Now, there are a lot of things that we have to remember about solving in order to be proficient at this. We have to remember just about everything we ever learned in algebra. Yep. We have to learn, or we have to remember how to use PEMDAS to peel things away from x. We have to remember that when you square root something, you get the plus and the minus. You have to remember how to factor. You have to remember so many things. But in addition to that, you also need to know all of these values. So these values come from the unit circle. All of these right here are our inputs, and all of these over here are our outputs. So for example, sine of pi over 6 is 1/2 because you go down the sine column, the input's pi over 6, you get 1/2. Cosine of pi over 6 is root 3 over 2. Everything that we have ever learned comes full circle when we are trying to solve these questions. So let's get right into it. Let's solve a few of them. So I want to start with sine of x plus the square root of 2 equals negative sine of x. We're going to start right here. And what we want to do is we want to figure out what are the x values that make this true? What are the x values that make sine of x plus the square root of 2 equal to the function negative sine of x? Now, the easiest thing to do is to just plug them both into Desmos and look at where they cross. So I'm going to title the left-hand side f of x, and the right-hand side I will title g of x, and then I'll change the colors so that we can see them. And everywhere they cross, every x value that they cross is a solution to this equation. And one thing that you will notice is it crosses in a lot of places. It crosses in infinite different places. So if you're answering this question on a test, on a quiz, and you don't know how to do it algebraically, you could always plug it into Desmos and find where they cross. Well, 5 pi over 4 is an answer. 7 pi over 4 is an answer. 13 pi over 4 is an answer. 15 pi over 4 is an answer, and so forth. It goes on for forever and forever. So we need to ask ourselves, well, how often does it repeat? Because if I had to list all of the places that it crossed by hand, I would be writing for the rest of my life. So is there a pattern? Is there a consistent gap in between each of our answers? And there is. Between here and here, that distance is 2 pi. Because the period of a sine function is 2 pi. So again, everything is coming full circle. that was a good joke because the unit circle, it's coming full circle. Yeah, I know you guys are laughing at home right now. So every 2 pi, it's repeating because that's the period of a function. And then right here, from 7 pi over 4 to 15 pi over 4, that is 2 pi. So really, you just have to find the first 2 values and then add 2 pi to that. So you can use Desmos to get your solutions, or we could solve this out by hand. And that's really what we're going to be doing, is solving this out by hand. So you want to remember your order of operations. You want to remember everything you've ever learned in math class before. And the first thing we want to do is we want to isolate our x. So we need to get all of the terms that have x on the same side. So these terms both have an x embedded in them. Well, we want to combine those. So to jump over the equal sign, we are going to add sine of x. When we add sine of x plus sine of x is 2 sine of x. Common misconception, a lot of people put sine squared. Sine squared only comes from sine times sine. So this is 2 sine of x plus the square root of 2 equals, well, negative sine plus sine is 0. Now, here's our term that has an x in it. We're trying to isolate our term with an x in it. We've got to subtract the square root of 2 to get it onto the other side of the equation. So these cancel, and we're left with 2 sine of x equals negative root 2. Now, really, we are trying to isolate just the x. We're trying to get just the x alone. And I want you to remember that the x is inside of the argument of sine. So I'm going to have to undo a sign at some point. But before I can undo the sign, I got to get rid of the 2. So I'm going to divide by 2 on both sides. And that's going to look like this. Sine of x equals negative root 2 over 2. You cannot divide that down into 1 because the numerator is in a square root symbol and the denominator is not. So you have to keep that, the square root of 2 over 2, negative root 2 over 2. So we're almost there. We're trying to get this x alone. Well, when you are undoing a positive, you use a negative. When you're undoing a squared, you use a square root. When you're undoing a cube root, you do a cubic. So how do you undo a sign? Well, all of those things that I just listed were inverse operations. The inverse operation of a sine function is the inverse sign. So it looks something like that, where you're going to put that little -1 as the notation for inverse. And algebra's golden rule is then we must do it on the other side as well. So it looks like that. What happens is the sine and the inverse sign cancel out, and you're left with just x over here. And then we are looking for the inverse sign of negative root 2 over 2. Now, an inverse sign is always giving you an angle measurement. And sometimes that measurement is in degrees, sometimes it's in radians, but an inverse, and I'm just going to say trig function, gives an angle measurement. So we are wondering, what is the angle measurement that gives us an output of negative root 2 over 2? We have this handy dandy sheet of paper right here. And here are sine values right here. And these are the angle measurements. And so we are going to specifically be looking at the radian section because almost everything we do in pre-calc is in radians, because radians are just a little bit more accurate most of the time. So because we did inverse sine, we're going to follow the sine column down. If it would have been inverse cosine, tangent, cotangent, secant, or cosecant. But because it's an inverse sine, we're going to follow this down. And we are specifically looking for negative root 2 over 2. So I'm scanning, and negative root 2 over 2 is at 5 pi over 4. So I'm going to put x equals 5 pi over 4. But I just want to check, are there any other places that our sign, again, this column right here, is negative root 2 over 2? And I'm scanning. Oh, there's another spot right there at 7 pi over 4. Now, like we talked about before, so I'm going to pull this back over here, there are infinite places that this crosses, but we do see it cross at 5 pi over 4 and 7 pi over 4. To write down all of the other places that they meet, you are going to take your first two values that you find using the unit circle, and you're going to add your period to that. So the period for this function that we're working on is 2 pi. So you would say plus 2 pi times n. N means integer numbers. And so n is really the number of rotations. So if n was 0 here, 2 pi times 0 would just be 5 pi over 4. If n was 1, it's saying, okay, do one full rotation later. And when you do one full rotation later, you're adding 8 pi over 4, and you get 13 pi over 4, which we also saw on Desmos. We're also going to add 2 pi n for this one, and that will give us the infinite solutions for when these two equations are equivalent. So hopefully you followed the steps of algebra, but also I hope that you made that connection right here, that this 2 pi n is giving us our infinite solutions. So I've got a couple more examples that are very similar to that I'll quickly work through, and then we'll check on Desmos. So what if we had sine of x minus root 2 equals negative sine of x? So everything is essentially the same as this one, but now we've got a minus right there. Well, we're going to start it the same way. We're going to add a sine of x here and here. That's going to cancel just like before. Sine plus sine is 2 sine equals 0. We're trying to isolate our term with an x, so we're going to add that square root of 2. It's going to cancel, and we're going to get 2 sine of x equals, and now it's a positive root 2. We're still trying to isolate the x, so we're going to divide by 2 on both sides, and now what we're going to have is sine of x equals root 2 over 2. To get the sine canceled out, we're going to inverse sine both sides, and that's going to leave us with x equals the inverse sine of root 2 over 2. So we want to find our answer in radians. We're going to take our handy dandy sheet of paper. Again, it's an inverse sine, so we're going to follow that sine column down. And we're looking for positive root 2 over 2. Here's our first one right here, pi over 4. So I'm going to put x equals pi over 4, and I'm going to put plus 2 pi n because I wanted to talk about every time it rotates. I'm going to find another one, 3 pi over 4. And again, I'm going to put plus 2 pi n because that talks about every time it rotates around. Those are going to be my answers. Now, you could use a calculator to find your answers, but it's not going to give you the exact ones if you're using radians. So if you take your calculator, you can go to, it's not popping up here. I don't know how to make this go away. Okay, you can click this right here. And when you click that, you can click functions. And here's our inverse sine. You could plug in square root of 2 divided by 2, but it gives you an approximation. If you want to know what it is in degrees, you switched it to degrees and you have 45 degrees. Then you could take the 45 degrees and you could multiply it by pi over 180 to get it in radians because you want almost all your answers in radians. So again, you could be using some of the things that you learned earlier in the year to help you get those right answers. Okay, so hopefully this video helped you understand the difference between identities and equations, and then how to solve really basic equations.